Okay, now what we are going to see is the first chapter of the 9th standard, that is maths में rational and irrational numbers. So we have got the question rational and irrational numbers. As such, syllabus point of view, this particular chapter has got a very limited amount of questions to be asked, or we can say most of the things are cancelled over here. Only 2 or 3 things in this chapter are important and need to be done. So we will follow only that part. But before we do that thing, we'll need to understand what are the rational and irrational numbers. We already know that in the number system, we have got n, which is the natural numbers. The natural numbers are the one which starts with 1 and goes to infinity. The next are the whole numbers. Whole numbers are the one which are going to start with 0 and go towards positive infinity. The next one are integers. Integers, also called as z. They are integers. Now integers are the one which starts from minus infinity to 0 to plus infinity. So that's the both sides, minus infinity to plus infinity. And then comes the real numbers. So R are real numbers. The real numbers again minus infinity to 0 to infinity. But over here the difference between this and this is that this contains all decimal values. So here in integers you do not have 1.5, 1.5, 1.53, 1.76 or 1 upon 3 or 2 upon 3 or minus 1 upon 3 or minus 3, 2 upon 4. Nothing like that. We don't have any kind of integers, or in integers we do not have any kind of decimals or fractions. But in case of real numbers, you have got all the decimals and all the fractions which are possible. So right from minus infinity to infinity में जितने भी numbers है 1.111111 1.53 53 53 42 43 कुछ भी anything, any particular number what you are going to take in decimal points or in whole numbers are available in real numbers. Then what is rational and irrational? So these real numbers are divided into 2 parts. One are rational and other is irrational. Now, a rational number is a number which, when you are having any fraction and that fraction gives you a number which is, so when like for example, if I am taking the number 2 upon 3, so this 2 upon 3, if I actually divide this 2 upon 3, what will happen? This is 3, this is 2, so it will be 0, 0 point. So 20, so it will be 6, 18, and then it will be 2 again, so 20, and again 6, then 20, so 18, so again 2 and 20, so 6, 6, 6, 6. So you can see it is nothing but 0.6666 recurring, right? Or else if you take, suppose we are taking 2 upon 5, then what happens? This is 5, this is 2, 0, ले लिया 20 किया तो 4 किया. So this is nothing but 0.4, so it has terminated over here. So when any number which is terminating or recurring is a rational number. So a rational number is the one which is terminating or recurring. So any number जब हम लोग उसको डिवाइड करते हैं और उसमें अगर मुझे रिकरिंग मिलता है, भले वो फिर 0.4345 4345 4345 4345 ऐसे मिल रहा है, पर वो रिकरिंग ही हो रहा है, then it is a rational number. Or if I am getting the answer as 5.3, that's it, or just 5, just 10, all whole numbers, then they are rational numbers. So what is the only option available for the non-terminating, the irrational one is that irrational numbers are non-terminating. So these are non-terminating or non-recurring. So if the value of the number keeps on going on and on without recurring itself, then it is called as a non-decaying. Now, the examples of the irrational number will be all non-perfect squares के square root. So square root of all the numbers which are not a perfect square. So this is square root. So all square roots. And secondly is value of pi. The actual value of pi, not 22.7. The actual value of pi is the irrational number. So if when I say, the example will be root 2, root 3, root 5, root 7, root 6 भी आएगा, root 6, root 7, root 8, root 9 नहीं आएगा because root 9 is 3. So root 8, root 10, all these numbers and pi, these are the examples of irrational numbers. So irrational number में we just have to think it this way. अगर root में है तो irrational है. Pi normally आता नहीं है. So for you important thing is that कोई भी चीज, कोई भी answer, if it is in a root, then it is a irrational number. Now what is the importance of this particular rational irrational? The main important thing over here is that the number, in case of your 9th standard or 10th standard, anytime when you are going now further, if your answer has got a denominator which is a root, like if the answer, suppose the answer of x is equals to 1 upon root 3. If the answer is 1 upon root 3, then I need to remove this root and convert it into a rational number. You see, because this now is an irrational number, so I need to make it, the denominator of my answer should never be an irrational number. That is the main idea. So अभी उसके लिए हम rationalization सीखेंगे तो बताऊंगा exactly उसको क्या करना है. But mainly that is the main application of rational irrational, that whenever the answer what you are getting is an irrational number with the denominator being irrational, you need to convert it in such a number जो rational number में हो जाए. Denominator, numerator irrational चलेगा, डिनोमिनेटर कभी भी इर्रेशनल नहीं होना चाहिए. न्यूमरेटर इर्रेशनल रहेगा तो चलेगा. ओके, सो दैट इज व्हाट इज द बेसिक कॉन्सेप्ट. नाउ we'll go through those questions which are very important and we need to know about in the exercise. So if I see the exercise number 1, so 1.1, the inserting the rational number between 2 numbers and 3 numbers, that is not important. In case your school does start with that thing or does that, something like that, we'll just take upon that thing later on. I need not waste my time in that thing right now. The second thing what they can ask is about exercise 1.2 also, nothing important. We will skip that 1.2 also. Exercise 1.3. Yeah, we will need to do certain things of exercise 1.3, that is the first part. Now the first part is important. You need to locate root 10 and root 17 in a number line. Now before that, let us understand how to draw or how to mark root. Like I know that this is a number line where this is suppose 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Now, if I want to mark root 2 on a number line, what I'll do is that I know that this distance is 1 centimeter, so I'll draw 1 centimeter over here like this. And then I will take a compass, take this much as the radius, and draw a curve like this. So I'll draw a curve like this. So from here to here. So then this is 1, this is 1. So this distance over here, that because this distance over here is root 2. Why is it root 2? Because of Pythagoras theorem. Let's see this one. This is 1 square plus 1 square is equals to this h square, hypotenuse square. So 1 square plus 1 square is 2. So 2 is hypotenuse square. So what is hypotenuse? So hypotenuse is equals to root 2. So you can see over here, this distance over here is root 2. So we are just taking that root 2 and marking over here. So this over here is root 2. The moment I want to draw root 3, I can just take one more line over here of 1 centimeter and take this as the radius and draw here like this. It will be root 3. Why? Because this is root 2. So it is like root 2 the whole square plus 1 square will be 2 plus 1 is equals to 3. So hypotenuse will be equal to root 3. समझा? This distance is root 2. We already marked that. This distance over here is 1 centimeter. This one is 1 centimeter. So root 2 the square, 2, 1 ka square 1, 2 plus 1 is 3. So square root will be, this is root 3. Understood how to draw this part? Now they ask us to find out root 10. Now for root 10, what we need to do is that root of 10, we know that 3 over here is nothing but root 9. Okay, so let me draw it once again. We need to draw root 10 and root 17. So it is exercise 1.3, sum number 1 ka 1. Or 1 ka 1 hi hai seedha. So we'll draw this thing. We have got this particular number line. This is 0, this is 1, this is 2, this is 3, this is 4. Okay. So now we are going to see. Now this, accordingly what will happen is, this is nothing but root 4 and this is nothing but root 9. This is nothing but root 16. Did you understand this? 1 is nothing but root 1, so not a problem at all. 2 is nothing but root 4. 3 is nothing but root 9 and 4 is nothing but root 16. I want root 10. Okay, what I need to draw is root 10. So what I'll do, at this point, if I draw a line of 1 centimeter here, what is going to happen? This is going to be 3 square plus 1 square is equals to hypotenuse square. So this is my hypotenuse. What is the hypotenuse going to be? It will be 9 plus 1 is equals to 10. So therefore hypotenuse will be equal to root of 10. So this is nothing but root 10. Now just take this as the radius and draw an arc like this. So this is nothing but my root 10. Samjha? Root 10. You take this as the radius and mark like this. ये point से ऐसे this way. Is it clear? Now the next question is root 17. So we'll take 16 वाला part. 16 वाला part लिया. इसको यहाँ पे भी 1 centimeter draw किया. We'll just check it out. 4 square plus 1 square is equals to 16 plus 1 is equals to 17. So hypotenuse is equals to root 17. Because this is nothing but hypotenuse square. So this is root 17. Take this as the radius and draw the arc like this. So this over here is root 17. This point and this point are my required answers. Did you get this thing? So this is one such question which they had asked in one of the prelim papers last year. So that's why we are having this particular question. The next what we are going to have is the question number 8 of exercise 1.3. In exercise 1.3, we have 1.3. We did the first one and now we are going to go for the 8th sum. And there are 6 questions in the, sorry, not 8th one. Yeah, 8th sum, yeah. 8th sum. Let's see. Okay, now the question over here is, you have to, this is the question that 0 point, it's actually over here is 0.33333 recurring. Okay, this is how the question is. You need to convert this into a fraction. यानी मुझे आंसर चाहिए समझे 3/10 जैसा कोई आंसर मुझे चाहिए. Okay, so let's find out how to find this. So first thing what we'll do is that we'll consider that let x is equals to 0.333. I'm just taking 3 decimal points. पूरा लंबा चौड़ा है. I'm just taking 3 over here. Now, if I multiply this both the sides by 10, so what will happen? Multiplying by 10, we get 10x is equals to 3.333. Because this is recurring over here, I can take, but I am taking only up to 3. So this is also like this. Okay, so it becomes 10x is equal to 3.333. So what will be the value of x? So here, if I am going to subtract this two, so 10x minus x is equal to 3.333 minus 0.333. So it will be 9x is equal to automatically just 3. One sec. So this thing. Right, so we see that x is equal to 3 upon 9. So x is equal to 1 upon 3. That's the answer. So 0.3333 can be written as 1 upon 3 as required in this particular question. The next one, let's see question number 2. We are doing all sums right now. That is 5.2 recurring. So x is equal to 5.222 dot dot dot. Accordingly, we'll do the same thing over here. 10x is equal to 52.222 dot dot dot. Subtracting, we get 10x minus x is equal to 52.222 minus 5.222. So 9x is equal to, we can see 47. Got it? So this becomes x is equal to 47 upon 9. Did you understand this thing? So that's the answer for the second question. Yeah, 1.3. Yeah. Right? That is 47 upon 9. Now we come to the third question. Question 3 is 0.404040 dot dot dot. That means x is equal to 0.404040. Now you can see here the recurring part are 2 decimals. So because there are 2 decimals, instead of multiplying by 10, I will multiply it by 100. So I'll get over here 100x is equal to 40.404040 dot dot dot. You can see what we are actually doing is that we are multiplying this number by such a number जिससे मेरे जितने भी recurring numbers, the number of digits which are recurring, वो सभी एक यहाँ पे आ जाए, बाकी सब recurring same बचे. So the recurring part over here and recurring part over here should remain same, and this should be easily subtractable. So accordingly we have over here that 100x minus x is equal to 40.404040 minus 0.404040. So that gives me as 99x is equal to 40. So x is equal to 40 upon 99. Understood? The next one is question number 4. It's 0.47 recurring. So it is 0.47 is recurring. So it is nothing but 0.4777 like this. So it is, we'll take x is equal to 0.4777. Therefore 10x is equal to 4.777 and 100x is equal to 47.777. Now why did I do this? See over here, this 4 was not in the recurring part. So first of all, I brought this into a condition wherein the complete decimal is recurring part and the number is outside. And then I took it in another one in which the recurring over here and recurring over here is same. So I can subtract them. So when I subtract this and this, so now I am subtracting 100x minus 10x is equal to 47.777 minus 4.777. So that gives me 90x is equal to 43. So x is equal to 43 upon 90 as the answer. Are we clear? So that was question number 4. Check the answer. question number 4 was this 40.90 and 43.90 years. You see the next question, that is sum number 5. Sum number 5 is 0.134. Now 34 is recurring. Yes, 34 is recurring. So again the same way, we are taking x is equals to 0.1343434. Therefore 10x is equals to 1.343434 and 100x is equals to 1. No, I'll have to take 1000x because I need 343434, so it will be 134.343434. Subtracting the two, I get it as 990 is equals to 133. So x is equals to 133 upon 990. That's the required answer. Is it clear? We come to question number 6. That's the last question. So x over here is 0.001001001. So therefore I am going to make it at 1000x is equals to 1.001001001. We can multiply 1000, so it is this way because 001 लिखने का कोई point नहीं है. So now subtracting this two, we get 1000x minus x is equals to 1.001001001 minus 0.001001001. That gives me 999x is equals to 1. So x is equals to 1 upon 999. So that is how you are expressing the numbers in the form of P upon Q, where P and Q both are integers and Q is not 0. So this is in the form of P upon Q. This is P and this is Q, where PQ is not equal to 0. So this is how you are finding out the values of the numbers which are recurring to a fraction. So this is the thing. And there is one more thing which is called search, but normally it is not required for you to learn this search. So basically root through, root 3, root 5, root 15 irrational numbers. In fact, these are special kind of irrational numbers because these are square roots of some positive rational numbers. See, because they are square roots of a positive number. Okay, they are square root of a positive number means they are real numbers, and that is why they are called as search. So one which cannot be written in squares of any rational number, जो भी हम लोग कोई लिख नहीं सकते कि like cube root of 2, you cannot write it in any kind of a irrational number, rational number. So that's why you call it as a surd. So it is, so cube root of 2, cube root of 5, cube root of 14 are numbers which are cube roots of some positive rational number which cannot be written as a cube of a rational number. Because what is cube root of 2? Anyway, I think we may cut this out because you are not asked any questions regarding search. So in fact, the whole last year, neither in the boards nor in any early region paper nor in any prelim paper, the search was not included. So there is no need of going to the search. So we can just skip that particular part of search. And now we can go for the I think I got the older textbook. Okay, we will now just see the next part, and that is the rationalization of the denominator. But before we do that, I'll just explain you how do you multiply the roots. So if I'm having some number, so multiplication of roots and addition of roots is something which I'll just explain you over here, right? First of all, is I want addition. So suppose I got over here 2 root 2 plus 3 root 2. Now when it is this way, you can just consider that root 2 is just an x. Then what will happen over here if it is 2x and 3x? It is nothing but 5x. So accordingly the answer will be 5 root 2. So when you are having the addition, it is possible to add only and only if the roots are same. So if the question is over here that root 2 plus 2 root 3, then the answer will be this itself. There is no possibility of adding it up as 2 root or 4 root 5 वगैरह नहीं हो सकता. So this itself is the answer. There is this second one में there is not possible to have anything. You can always say 2 bracket and root 2 plus root 3, but you cannot write anything further than this. So in addition or subtraction, same with the subtraction, 3 root 2 minus 2 or let's say minus root 2 will be nothing but 3 minus 1 is 2, so it will be 2 root 2. That will be the answer. So we are just adding and subtraction में root 2, root 3 ये जो भी है, अगर वो same है, if the variable, you can consider it as a simple variable, so if they are same, only then you can add or subtract. What happens when you multiply? So it's the same thing. If it is multiplied 2 root 2 into 3 root 2 if it is there, then you are multiplying 2 and 3 completely. So 2 into 3 and root 2 into root 2. So this is number 6 into, now root 2 into root 2 is 2. So therefore answer is 12. Why is it 2? You know in exponents, we had done earlier last year also, that what is root 2? 2 into 1 upon 2. What is, so this is into 2 into 1 upon 2. What is a raised to m into a raised to n? It is nothing but a raised to m into a raised to n is equals to a raised to m plus n. So here it is 2 raised to 1 upon 2 plus 1 upon 2, which is nothing but 2 raised to 1. Got it? That's the reason root a into root a is equals to a. Always remember this thing. Root a into root a is a. So anything multiplied by itself, it will be the same number itself. So root 5 into root 5 is 5. Root 10 into root 10 is 10. Root 7 into root 7 is 7. Similarly, root 3 into root 2 will be equal to root 6. Okay? 3 root 3 into 2 root 5 will be nothing but 3 2s are 6 into root 15. Understood? So this is how you are going to multiply. Even division is just cancellation. You don't normally use division over here. So division it will remain as it is. Like if it is 2 root 3 upon 2 root 2, then this 2 cancel, it becomes root 3 upon root 2. That's it. You are not doing anything else over here. So this is in case of division, multiplication, addition, subtraction of square roots. We will require this in our last exercise, that is 1.5.